Hi dear friends, now I am back again with another interesting topic in cybersecurity, which is sniffing. Now someone if sends an email to someone in between, if anyone can read it, isn't it a very bad thing? This is what happens in sniffing. Now before I go to a technical definition of sniffing, we must be aware of what key terms like promiscuous mode, the working of hub and switch, and what NIC card is. NIC Network Interface Controller is a computer hardware that connects a computer to a network. Promiscuous mode. In networking, promiscuous mode allows a network device to intercept and read each network packet that arrives in it. Hub by default allows promiscuous mode, but switch does not. However, we can make the switch to work in promiscuous mode by several exploits. Sniffing is a process of capturing packets by intercepting it, converting the NIC card of the system in promiscuous mode, and allows us to see all open ports, all sorts of traffic passing in the network. Sniffing helps us to see all the email and DNS traffic, all protocols, viewing sensitive information such as credential details and other important information. Sniffing can be used both for good and bad purposes. If used for good purposes, it can be used just for monitoring and troubleshooting purpose. However, if for bad purpose it is used, it can be used for stealing sensitive information. Types of sniffing. Now there are two types of sniffing, active sniffing and passive sniffing. In active sniffing, sniffing is done using a switch-based network. In this type of sniffing, we inject ARP or Address Resolution Protocol packets to the Content Addressable Memory or CAM table. The reason we do this is because we flood CAM table which keeps a track of which host is connected to which port. Passive sniffing. In passive sniffing, sniffing is done in a hub-based network. In this type of sniffing, we intercept and view the network traffic but does not alter it in any way. Now through sniffing, we can do several attacks such as man-in-the-middle attack, ARP poisoning attack, rogue DHCP attack, and SSL stripping. Let us begin with the first type of attack we can do through sniffing, which is man-in-the-middle attack. In man-in-the-middle attack or MITM attack, the attacker intercepts the network, inserts itself between the communication, and tries to steal sensitive information. The common targets of MITM attacks include online shopping sites, online banking sites, any other sites where you have to log in before accessing account, and credit card details, etc. But this is a diagrammatic view of how MITM attack would look like. In normal case, the host is sending a request to a target and getting a response from the target. But when done through MITM attack, when the host is sending a request to the target, in between there stays an attacker which is intercepting the request and maybe sending a false request to the target. ARP or Address Resolution Protocol is a type of protocol used for converting IP addresses into MAC address. Spoofing ARP messages is also known as ARP Poisoning Attack. In ARP Poisoning Attack, a large number of forged ARP request and reply packets are sent to the switch to overload it. The result of switch getting overloaded is that it becomes set in forwarding mode, allowing the attackers to perform sniffing easily. Step 1. Enable IP forwarder. IP forwarder must be enabled. It's required to redirect traffic through attacker PC. Disable set is equal to 0 and enable is equal to 1. Echo returns /proc/sys/net/ipv4/ip_forward. View the value set for IP forwarding. This will return a value 1 if not repeat above step. Now this is step 2 of ARP poisoning attack, IP tables NAT. Requests coming on port 80 will be redirected to user-defined port number. With the IP table NAT rule, the victim PC will get internet through attacker PC. IP table space dash T space NAT space dash A pre-routing space dash P space TCP space destination space dash port 80 space dash J redirect O dash port 8880. Then IP table space dash T space NAT space dash A space pre-routing space dash P space TCP space destination dash port space 443 space dash J redirect space O dash port 8883. Now step 3, which is ARP spoofing attack. ARP spoof attacks on victim PC and gateway address. The command for it is ARP spoof space dash I space Ethernet 0 space dash T space 192.168.1.23 space 192.168.0.253, which is a gateway address. Now in Linux, ARP spoof attacks on gateway address ARP spoof space dash I space 80 space dash T space 192.168.0.253 and space 192.168.1.23, which is the IP address of victim PC. Now we see the third type of attack that can be done through sniffing, which is rogue DHCP attack. DHCP, or Dynamic Host Configuration Protocol, is a protocol used for assigning IP addresses and configuring other network parameters dynamically. In rogue DHCP attack, the attacker makes the victim assign fake IP addresses, making the client believe they are actually connected to a legitimate gateway. DHCP starvation attacks. In DHCP starvation attack, the MAC addresses are spoofed and then the attacker sends a large number of requests to the DHCP to exhaust the DHCP server. This allows the attacker to create a rogue DHCP server on their system, and the new DHCP request comes, they are responded by the attacker. Now, last but not the least, the attack which we can do through sniffing is SSL Stripping Attack. SSL or TLS is a secure layer protocol that works by encrypting the connection between the client and server. It works by user sending an insecure HTTP request. The server then sends an insecure HTTP request to secure HTTPS request, and then a connection is established. In SSL stripping attack, the attacker continues to intercept the HTTP request and sends it to the secure HTTPS layer, passing through the attacker. This is a screenshot of how the SSL stripping attack would look like. The host in normal case should go to the SSL encrypted HTTPS layer, but due to the SSL stripping attack, the request will go to the attacker and then it will get sent to the server. Thank you. Stay tuned for the next edition.